Hello again. In this next video, we're going to be solving inequalities. I just wanted to remind you quickly of the rules for graphing. We're going to use an open circle on our graph when we're dealing with a less than or greater than sign. We're going to use a closed circle on our graph when we're dealing with an equality. And to shade less than values means to shade to the left. To shade greater than values means to shade to the right. So let's see what this looks like while we're also solving. Solving inequalities is a whole lot like solving equations, but there's this mega difference right here. Fill this in with me. You must flip the inequality when you multiply or divide by a negative value. You must flip your inequality when you multiply or divide by a negative value. Now, it won't happen all the time, only when you multiply or divide by a negative value. Okay, let's try number 9 as our first example. I'm going to follow all the rules I followed when solving equations. I'm writing out PEMDAS here, and I know I'm going to work backwards. So step 1 here is to get rid of this addition of 2. I'm going to subtract 2. Subtracting is not a reason to flip the inequality sign, so it remains a less than. Negative 4 take away 2 is negative 6. Now I need to remove this positive 3 that's multiplying the x, so I'm going to divide by a positive 3. Dividing by a positive is not a reason to flip the inequality sign, so my final answer is x is less than negative 2. Well, I'm going to put negative 2 on my number line. Negative 2 is between negative 1 and negative 3. You can fill in the rest of the tick marks if you'd like. There's no equal sign, so I use an open dot to represent that it's not equal to, and to go less than, I would shade to the left. Now I'm showing you all the values that are part of the solution set. Okay, let's flip the page here and do one that's a little tougher. Let's take on number 15. No, let's take on number 13, excuse me. Okay, it's still a two-step equation. I know I'm working backwards through PEMDAS, which means I need to get rid of the subtraction first. To get rid of a subtraction, I add, so I'm adding 5 to both sides. Adding is not a reason to flip an inequality sign. 19 plus 5 is 24. Next, I need to get rid of this negative 2 that's multiplying the x. So to get rid of a negative, I need to divide. And this is where bells need to be going off in your brain. When you divide by a negative number, you must flip the inequality sign. 24 divided by negative 2 is negative 12. That's a big difference to say that your answers are greater than negative 12 versus less than negative 12. I'm going to load up my number line. Negative 12, negative 11 is greater than that. Negative 13 is less than that. Put my closed dot on negative 12 to represent equality. And my solution set is greater than negative 12. So I am shading to the right. Let's do one more example. Let's try number 19, one of the toughest on the page. Don't be scared of that fraction in there. I'll remind you of what to do. First things first, this 4 is not attached to the x, so it's an addition. This negative 1/3 is attached to the x, so it's a multiplier. I need to get rid of addition first, so I'm going to subtract 4 from both sides. Subtracting is not a reason to flip your inequality sign, so it remains a greater than. If you remember from our study on solving equations, the easiest way to get rid of a fraction is to multiply by the reciprocal, and I want to put the negative on the 3. Ding, 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 ding. This is a flip moment. If you multiply by a negative number, you must flip your inequality sign. The reciprocal